Here's the riddle your CIO hasn't solved. Is AI just another workload to shove onto the server farm, or a fire-breathing creature that insists on its own habitat, GPUs, data lakes, and strict governance temples? Most teams gamble blind, and the result is budgets consumed faster than warp drive burns antimatter. Here's what you'll take away today: the 5 checks that reveal whether an AI project truly needs enterprise scale, and the guardrails that get you there without chaos. So, before we talk factories and Starship crews, let's ask, why isn't AI just another workload? Why AI isn't just another workload? AI works differently from the neat workloads you're used to. Traditional apps hum along with stable code, predictable storage needs, and logs that tick by like clockwork. AI, on the other hand, feels alive. It grows and shifts with every new dataset and architecture you feed it. Where ordinary software increments versions, AI mutates, learning, changing, even writhing depending on the resources at hand. So the shift in mindset is clear. Treat AI not as a single app, but as an operating ecosystem constantly in flux. Now, in many IT shops, workloads are measured by rack space and power draw. Safe, mechanical terms. But from an AI perspective, the scene transforms. You're not just spinning up servers. You're wrangling accelerators like GPUs or TPUs, often with their own programming models. You're not handling tidy workflows, but entire pipelines moving torrents of raw data. And you're not executing static code so much as running dynamic computational graphs that can change shape mid-flight. Research backs this up. AI workloads often demand specialized accelerators and distinct data access patterns that don't resemble what your databases or CPUs were designed for. The lesson: plan for different physics than your usual IT playbook. Think of payroll as the baseline: steady, repeatable, exact. Rows go in, checks come out. Now contrast that with a deep neural net carrying 100 million parameters. Instead of marching in lockstep, it lurches. Progress surges one moment, stalls the next, and pushes you to redistribute compute like an engineer shuffling power to keep systems alive. Sometimes training converges, often it doesn't. And until it stabilizes, you're just pouring in cycles and hoping for coherent output. The takeaway: unlike payroll, AI training brings volatility, and you must resource it accordingly. That volatility is fueled by hunger. AI algorithms react to data like black holes to matter. One day your dataset fits on a laptop, the next you're streaming petabytes from multiple sources, and suddenly compute, storage, and networking all bend towards supporting that demand. Ordinary applications rarely consume in such bursts, which means your infrastructure must be architected less like a filing cabinet and more like a refinery. Continuous pipelines, high bandwidth, and the ability to absorb waves of incoming fuel. And here's where enterprises often misstep. Leadership assumes AI can live beside email and ERP, treat it as another line item. So they deploy it on standard servers, expecting it to fit cleanly. What happens instead? GPU clusters sit idle, waiting for clumsy data pipelines. Deadlines slip, integration work balloons. Teams find that half their environment needs rewriting just to get basic throughput. The scenario plays out like installing a galaxy-wide comms relay, only to discover your signals aren't tuned to the right frequency. Credibility suffers, costs spiral. The organization is left wondering what went wrong. The takeaway is simple: fit AI into legacy boxes and you create bottlenecks instead of value. Here's a cleaner way to hold the metaphor. Business: it is like running routine flights. Planes have clear schedules, steady fuel use, and tight routes. AI work behaves more like a warp engine trial. Output doesn't scale linearly, requirements spike without warning, and exotic hardware is needed to survive the stress. Ignore that and you'll skid the whole project off the runway. Accept it and you start to design systems for resilience from the start. So the practical question every leader faces is this: how do you know when your AI project has crossed that threshold, when it isn't simply another piece of software but a workload of a fundamentally different category? You want to catch that moment early, before doubling budgets or overcommitting infrastructure. The clues are there: demand patterns that burst beyond general-purpose servers, reliance on accelerators that speak CUDA instead of x86, datasets so massive old databases choke, algorithms that shift mid-execution, and integration barriers where legacy IT refuses to cooperate. Each one signals you're dealing with something other than business as usual. Together, these signs paint AI as more than fancy code. It's a living digital ecosystem, one that grows, shifts, and demands resources unlike anything in your legacy stack. Once you learn to recognize those traits, you're better equipped to allocate fuel, shielding, and crew before the journey begins. And here's where the hard choices start. Because even once you recognize AI as a different class of workload, the next step isn't obvious. Do you push it through the same pipeline as everything else? Or pause and ask the critical questions that decide if scaling makes sense? That decision point is where many execs stumble, and where a sharper checklist can save whole missions. 5 questions that separate pilots from production. When you're staring at that shiny AI pilot and wondering if it can actually carry weight in production, there's a simple tool. 5 core questions, straightforward, practical, and the same ones experts use to decide whether a workload truly deserves enterprise-scale treatment. Think of them as your launch checklist. Skip them, and you risk building a model that looks good in the lab but falls apart the moment real users show up. We've laid them out in the show notes for you, but let's run through them now. First, scalability. Can your current infrastructure actually stretch to meet unpredictable demand? Pilots show off nicely in small groups, but production brings thousands of requests in parallel. If the system can't expand horizontally without major rework, you're setting yourself up for emergency fixes instead of sustained value. Second, hardware. Do you need specialized accelerators like GPUs or TPUs? Most prototypes limp along on CPUs, but scaling neural networks at enterprise volumes will devour compute. The question isn't just whether you can buy the gear, it's whether your team and budget can handle operating it, keeping the engines humming instead of idling. Third, data intensity. Are you genuinely ready for the torrent? Early pilots often run on tidy, curated datasets. In live environments, data lands in multiple formats, floods in from different pipelines, and pushes storage and networking to their limits. AI workloads won't wait for trickles. They need continuous flow or the entire system stalls. Fourth, algorithmic complexity. Can your team manage models that don't behave like static apps? Algorithms evolve, adapt, and sometimes break the moment they see real-world input. A prototype looks fine with one frozen model, but production brings constant updates and shifting behavior. Without the right skills, you'll see the dreaded cliff, models that run fine on a laptop yet collapse on a cluster. Fifth, integration. Will your AI actually connect smoothly with legacy systems? It may perform well alone, but in the enterprise it must pass data, respect compliance rules, and interface with long-standing protocols. If it resists blending in, you haven't added a teammate. You've created a liability living in your racks. That's the full list: scalability, hardware, data intensity, algorithmic complexity, and integration. They may sound simple, but together they form the litmus test. Official frameworks from senior leaders mirror these very 5 areas, and for good reason. They separate pilots with promise from ones destined to fail. You'll find more detail linked in today's notes, but the important part is clear. If you answer yes across all 5, you're not dealing with just another workload. You're looking at something that demands its own class of treatment, its own architecture, its own disciplines. This is where many projects reveal their true form. What played as a slick demo proves, under questioning, to be a massive undertaking that consumes budget, talent, and infrastructure at a completely different scale. And recognizing that early is how you avoid burning months and millions. Still, even with the checklist in hand, challenges remain. Pilots that should transition smoothly into production often falter. They stall not because the idea was flawed, but because the environment they enter is harsher, thinner, and less forgiving than the demo ever suggested. That's the space we need to talk about next. The pilot to production death zone. Many AI pilots shine brightly in the lab, only to gasp for air the moment they're pushed into enterprise conditions. A neat demo works fine when it's fed one clean dataset, runs on a hand-picked instance, and is nursed along by a few engineers. But the second you expose it to real traffic, messy data streams, and the scrutiny of governance, everything buckles. That gap has a name: the pilot to production death zone. Here's the core problem. Pilots succeed because they're sheltered, controlled inputs, curated workflows, and environments designed to flatter the model. Production demands something harsher: scaling across teams, integrating with legacy systems, meeting regulatory obligations, and handling data arriving in unpredictable waves. That's why so many projects stall between phases. The habits that made a pilot glow don't prepare it for the winds of the real world. The consequences stack quickly. Data silos cut supply lines with entire departments guarding information in incompatible formats. Governance gaps leave access controls and permissions improvised. Fine in a test, fatal under audit. Hardware shortfalls slow training and inference when CPUs can't keep pace and accelerators aren't built into the pipeline. And looming over it all, compliance frameworks appear like invisible tripwires, especially in industries facing strict privacy and fairness regulations. These trip hazards aren't unique. They're highlighted again and again in industry research as the obstacles that block AI from scaling. Ignore them, and your success ends as stranded prototypes gathering dust. One vivid image says it all. Running AI beyond the pilot stage is like climbing past the thin air altitudes on Everest. Below a line, progress flows. Above it, every step requires deliberate discipline, oxygen, and teamwork. In AI terms, that oxygen comes from infrastructure, governance, and automation. The metaphor works once, but the point is sharper when you leave the imagery and face the blunt truth. Your team cannot muscle through the death zone by enthusiasm alone. Technically, the fix has a name: MLOps. That means automating the test, deploy, monitor loop so models behave predictably when scaled. Instead of handcrafted notebooks pushed directly into production, you develop standard pipelines that test models, validate them, deploy them through reproducible steps, and monitor their drift in the wild. MLOps transforms AI from a one-off experiment into a production system with the same reliability you expect from payroll software or transaction processing. Without it, every handoff is shaky, every update a gamble. Concrete pain points prove the case. That perfectly tuned model that excelled in isolated testing, once faced with live streams, latency targets in milliseconds, and hundreds of client requests at once, it stutters. A dashboard that looked fluid for one team runs like molasses when 1,000 employees log in. Engineers race to patch performance gaps, but the reality is unavoidable. Fixes after the fact cost more than proper orchestration from the beginning. Governance adds another source of collapse. What slid by in a proof of concept, a quick admin override, a shortcut for permissions, becomes an immediate compliance headache once auditors step in. Regulations and audit requirements aren't optional extras. They're mandatory frameworks that shape production itself. Enterprises that wait until after pilots scale find themselves stuck rebuilding foundations that should have been there from day one. Meanwhile, the shortage of skilled hands intensifies the strain. Pilots can survive on a few sharp engineers improvising clever workarounds. Enterprise scale requires specialists across data engineering, AI ops, and infrastructure. Without codified workflows, each step gets reinvented and weeks vanish with no forward progress. Leadership watches the clock, finance tracks the cost, and patience drains. The promise of AI starts to resemble a stalled project rather than a transformative capability. It's tempting to think the solution lies in more talent or more machines, but piling on without orchestration is like adding climbers to a mountain team without ropes or oxygen, bodies moving, but with no chance of coordinated survival. What actually rescues projects here isn't raw power, it's orchestration, a unifying discipline that connects data flows, ensures compliance, and automates deployment. It's not flashy, but it's life support for AI crews trying to push beyond demos. This is the unavoidable lesson. Enterprise AI cannot be improvised. Success comes from factory-grade repeatability, templates for pipelines, automated testing, governance baked into workflows, and resources dynamically managed. With that foundation, the death zone isn't a graveyard, it's a passage you can cross systematically. Without it, every step is fragile improvisation, destined to collapse under pressure. And once you see the scale of coordination required, the next question emerges: how do you actually build that orchestration layer? Not as scattered patches or isolated teams, but as a central command deck where the chaos is disciplined, roles are defined, and systems move in sync. Enter the AI Factory, Starfleet Command for Enterprise AI. Picture this. Instead of every team improvising alone, you've got a unified bridge where DataOps, MLOps, and GenAIOps operate like officers at their stations. Engines, shields, navigation, each with their own duty, but coordinated through a single command chain. That's the premise here. Not another tool tacked on, but the orchestration layer that keeps the ship together under stress. Without a central layer, enterprise AI looks more like a brawl between decks. Data engineers spin out pipelines in one corner, ops write rules in another, researchers sling models over the rail, no shared map, no rhythm. What you get is overlapping scripts, redundant systems, and security holes big enough to fly a shuttle through. That chaos isn't a rare accident. It's what happens when scaling AI is left to scattershot effort. The factory flips that script. Think of it less as a new gadget and more as a conductor's stand. The sections are your data lakes, training pipelines, cloud accelerators, and instead of crashing over each other, they play in time. In practice, this session's demo includes features like an auto-lake approach that centralizes fragmented data stores into one consistent environment. Pipelines finally run against a steady source of truth, and governance has something real to enforce. Hungry AI models don't get starved because the data stream went dry. Templates are the next card on the table. Pilots routinely fail to scale because every project provisions infrastructure a little differently, scripts tasks in custom ways, and leaves half the system undocumented. Templates fix the drift. Build once, stamp again and again. The gain is factory-grade reliability where pressing Go sets up a pipeline the same way every time. Instead of months wiring bespoke assembly, you're looking at repeatable deployment in days. Then comes control of access. Role-based access control sounds dull until you've lived without it. Without guardrails, junior staff stumble into GPU clusters, auditors have to sneak through side doors, and no one can say who changed what. RBAC restores order. Data engineers see pipelines. Scientists get their sandbox, auditors observe without fiddling. Clear lines, fewer risks, smoother collaboration. Networking is the invisible artery. Scale without proper channels and connections tangle as workloads sprawl across teams. The factory answer is private networking paths. Endpoints are contained, throughput is tuned for heavy data demands, and risk of leakage drops. Think of it as ensuring the comms array carries only your signals, not stray broadcasts bleeding into the line. Hardware orchestration is often the most expensive pain point. GPUs and TPUs are powerful, but unmanaged, they sit idle and drain funds. In the factory model, accelerators plug into a broader schedule. Drivers provisioned automatically, tasks lined up, capacity balanced. Instead of wrestling with the warp core every morning, you command it through a repeatable sequence. Hardware behaves like part of the system, not a standalone diva. Organizations experimenting with this model report that setups which once dragged across weeks of ticketing shrink drastically. That's not magic, it's the discipline of coordinated workflows, governed access, and unified orchestration. When the lifeboats are lashed into one vessel, the voyage becomes manageable. What anchors the reliability isn't just the tooling, but the frameworks behind it. The AI factory approach leans on cloud best practices akin to Microsoft's cloud adoption and well-architected guidance. That integration ensures workloads are developed with security, scalability, and compliance structured in from the start, not bolted on later under duress. It protects projects from the trap of fragile demos that collapse when exposed to enterprise realities. Starfleet's metaphor fits neatly here. Officers don't improvise core duties. Shields rise when ordered, engines fire on cue, comms sync to one channel. That choreography is what this model delivers. It takes scattered efforts, assigns them proper lanes, and binds them into a ship running on order rather than chaos. At the heart, the factory unites data ops, ML ops, and Gen I ops into one orchestrated system. The outcome is scale that's repeatable, not luck-based, AI that graduates safely from lab demonstration to enterprise demand. Teams gain confidence because they know the bridge exists, and discipline threads through each phase of work. But a bridge only sets direction. What drives actual thrust are the engines below, the accelerators straining, the pipelines flooding with data, the models shifting mid-course. And it's there, in the machinery beneath the deck, where the next set of challenges demands your attention. The engine room, hardware, data, and algorithm complexity. Every starship has an engine room. And for enterprise AI, that engine is powered by 3 volatile subsystems: hardware accelerators, the data streams that feed them, and the algorithms that refuse to stay still. Miss the balance and the whole vessel stalls. Get them working in rhythm and you have the thrust to scale. Start with hardware. CPUs can handle routine applications, but AI workloads chew through parallel math at a pace only GPUs or TPUs can satisfy. These accelerators aren't plug and play. They bring their own libraries, schedulers, and quirks, more like exotic reactors than office servers. The danger is idle racks glowing without contribution. The practical check: measure GPU scheduling and monitor idle rates. If accelerators sit silent while demand piles up, your resources are misaligned long before you consider scaling. Then there's the endless hunger of data. Every serious model demands a torrent, not a trickle. Business apps survive on modest queries and nightly batches. AI pipelines require fast, continuous throughput with negligible latency. Storage no longer just holds, it must push, handle concurrency, and deliver bandwidth, or else your expensive accelerators do nothing but wait. Research underlines this with the chinchilla insight. Bigger models alone don't yield gains without proportionately larger training datasets, and imbalance wastes compute. That means both size and quality matter. Garbage in, garbage predictions out. Your check here is straightforward. Stress test the pipeline under realistic real-time load. If throughput collapses or queues form, your engines will sputter in production. Finally, the strangest part of the engine room: algorithmic complexity. Payroll software ticks step by step with boring predictability. AI models behave more like plasma clouds. They shift shape mid-run, ballooning with new training cycles or collapsing under certain inputs. Computation graphs for modern neural nets change structure dynamically, and that instability hits resource allocation hard. Without profiling tools and dynamic schedulers, your infrastructure ends up blindsided. A practical safeguard: insist on strict model versioning and continuous profiling. That way you see when a graph balloons and you can adjust compute before the system buckles. Consider the cautionary tale of an enterprise that invested heavily in GPUs but fed them with weak pipelines. The accelerators lined up, humming like statues, while data trickled in too slowly to matter. Jobs queued up, but nothing escaped the bottleneck. The result? Money burned, time lost, and credibility damaged. Their lesson became universal. Scaling AI demands balance across hardware supply, data flow, and algorithmic behavior, never one in isolation. The payoff of doing this right is simple: equilibrium. Hardware fires only when streams are ready. Data pipelines flow without starving accelerators. Algorithms shift within a monitored framework so resource allocation adapts instantly. It's orchestration inside the engine room itself, not chaos disguised as progress. And the diagnostic checks are the compass. Monitor accelerator idle times, run pipeline stress tests, version and profile your models. With those, you know when the balance holds and when repair is urgent. Yet balance alone isn't enough. Without rules and governance, the system burns itself out. Scaling is never just about raw horsepower. It's about coordinated systems where every moving part respects limits and flows together. That's the edge between a working Starship engine and a lab experiment frozen mid-flight. And this points us back to the larger picture. AI isn't sustained by a single upgraded machine or a flashy cluster. It's an interconnected system where hardware, data, and algorithms must sync under governance and orchestration. Without that, even the strongest engine stalls out on the launchpad. Conclusion scaling, AI, isn't about piling on hardware, it's about treating the whole system as an ecosystem. Orchestration, governance, and adaptive infrastructure aren't extras. They're the triad that keeps AI aligned with strategy and resilient under compliance. Ignore them and projects drift. Embrace them, and you turn lab demos into dependable enterprise capability. Executives see the shift already. Industry surveys, linked in the show notes, report over 90% planning to increase AI investment in the next 3 years. That money needs structure. Enterprise scale AI, factory-style orchestration is the bridge. The choice is plain: chaos at the helm or crew in command. If this lower drop upgraded your power level, hit subscribe so future transmissions autopilot into your feed. Rate the show, drop your sharpest one-liner in the comments, and check the show notes for sources and links. See you on the next frequency.